functional sense. So I have just shown in this terminal here an example content of shell.next file, and this is a very common shell.next script that developers use to containerize a development environment. For example, here it's containerizing the presence of hello, lcov, Poco library, Google test, and C++ compiler tools into this derivation, and specifying the build inputs. But how do we actually make sense of the shell.next? It really looks weird, and the first time that I have seen this syntax, it's really difficult to make sense or get a grip of what is this all about or what is doing. But this script will work if we invoke next shell. It will give us the containerized isolated environment as expressed in this script. So how do we understand this shell script? The key to understanding this shell script is one character, okay? It's only to take note of one character. There is one character in this entire shell.next that is a tell that gave it all of what this script is all about. And that character is this one, the colon. The colon character in the next syntax is to indicate that it is a function body. It is a function body. I have lectured previously how to implement a function that accepts one argument and increments it with one. And in that tutorial, we saw that when we declare a function, we put a colon to separate the argument from the body. So in this function, this entire shell.next is actually a lambda function or a function declaration, wherein this line here is the expected argument of the function, and the whole body here is the function's implementation using the let_n keyword. Alright, so but since this is a miniature next environment in my Android phone, I could not completely run this shell.next. So to continue my explanation, I will have to simulate a similar expression having this same form. So let me switch to the other terminal. I have ready another file here, and that next. Okay. First, let me delete the unwanted stuff to simplify the explanation, and save this. So I hope that you will agree that this simplified model of n.next more or less mimics the overall structure of this particular shell.next. So there is a colon, and this particular lambda expects an argument as an argument which is a set containing the fields A and B, and the function body adds A and B plus n, which is defined as a constant 100. So let us load the REPL. Because n.next is not a set, we will not be able to load it via the :l command. So this will give an error. As I had explained previously, if had n.next been a set, then we can load it like this, but n.next is a lambda function, so we cannot load it like that. Well, just curious, let me try. Let me try something here. Oops, not accepting it. How about this? This is just a try, by the way. This is not part of the lecture. I'm just experimenting something here. We can learn also from experimenting. Yep, so indeed we cannot load it like that. I've tried, but we can't. So the way to load a lambda next expression is via import. So we assign it to the variable n, and we import n that next file. So the lambda function is now assigned to the n variable, and n is a function pointer or a lambda. To verify what the type of a variable, a handy way to do it also is via the built-in type of. It specifies the variable and it will tell you that it's a lambda. Or if you say 7, then it's an integer, or if the word apple, then it's a string. So this is a handy way to interrogate the type of a variable. So having assigned the lambda into the variable n, we can now call the lambda. And since the lambda expects an argument which is a set containing the fields A and B, then we pass it with that expecting argument A, B, and 3, and B, 4. So we are now about to call the lambda function, passing it with the expected argument a set containing the fields A and B, because that is how or what the function is expecting. And if we switch a little bit, the function expects an argument which is a set containing fields A and B, and the implementation of the function adds the A and B plus 100. Just go back to the REPL and press enter, and we have 107. Thus, it is the correct answer. 3 plus 4 plus 100 is 107. The function is correctly returning the expected result. Let us try calling it with a missing field B. And it gave us an error because B is expected as it is in the implementation here. And since B is missing, so it gave an error. Okay. How about if we pass it with an extra field like Q? And since the function is defined to only have fields A and B, this particular argument caused the function to fail because the function did not expect the presence of the field Q, it only expects A and B. The way to make the function still work despite the presence of extra fields is to add a dot dot dot. By adding a dot 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 in the dictionary in the set, we are telling that the function allows additional fields, although it only uses A and B, but it will still accept if there are fields from the set, there are extra fields. It will still do the addition of A and B plus 100. Let us reload. Okay, and now let us call the function. A equals 3, B equals 4, and the extra field Q equals 6. And indeed the function is now successfully returning. It's no longer gave an error because we added the dot dot dot, and the function is fine with that. Even if we do P 88, still fine. Okay. However, if there is a missing field which the function expects it because it is in the implementation of the function, such as B, if B is missing and there are still extra fields, then there's no helping that. It's still an error because B is used in the function and it's missing in the set, so that gave an error. So the dot 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 is only to make the set contain extra fields, and still the function is fine with it. So going back to shell.next, so this lesson is just to make sense of a very common next expression, such as shell.next having this colon here, which is really to indicate that this shell.next is a lambda function, and we created a miniature n.next to mimic the format of the shell.next, and in order for us to make sense of what the syntax is all about and what do they mean. So I hope that this tiny tutorial is helping anyone who is trying to learn Next Package Manager and learning its syntax and and its peculiar and weird syntax, and it is very different than what we used to know. So tutorials like this, simple examples, really help, at least in me, and I hope that it also can help other folks out there trying to understand this wonderful package manager, this wonderful programmable package manager called Nex, and it is the package manager used in NextOS or Nexus Linux distribution. But not only in that distribution, Nex package manager can also be used in Ubuntu, in Mac, in Fedora, and in other POSIX Linux systems out there. So I'm not an expert, but I'm just trying. I'm also learning as I continue to use this new way of containerization technology. This is all for now. I'm your mobile teacher signing off. I'm actually in a coffee shop. I'm waiting in a queue here, trying to pay my electricity bill, and that's why I'm just making this tutorial to not waste time. Thank you, and have a nice day, folks. Stay functional.